and welcome back to the PyTorch basics. In this video, we're going to talk about rank, axes, and shape. So the concepts of rank, axis, and shape are the tensor attributes that will concern us most in deep learning. A lot of people use them interchangeably, and some people give them the same definition. So I thought it was good to clarify the difference between these three different concepts. These concepts build on one another, starting from rank, then axis, and building up to shape. So keep any eye out for this relationship between the three terms. Let's start by defining what a rank of a tensor is. The rank of a tensor refers to the number of dimensions present within the tensor. Suppose we are told that we have a rank 2 tensor. This means all of the following. A rank 2 tensor might be a matrix, a 2D array, or a 2D tensor. We are introducing the word rank here because it is commonly used in deep learning when referring to the number of dimensions present within a given tensor. So rank just refers to the dimensions of a matrix. Now let's see an example for rank. A rank 0 tensor means it has 0 dimensions. That is just a scalar. A rank 1 tensor is a vector. And a rank 2 tensor is a matrix because it has 2 dimensions, one along the rows and one along the columns. A rank 3 tensor is just a cube, and a rank 4 tensor is also represented as a block of blocks. Now let's see rank and indexes. The rank of a tensor tells us how many indexes are required to access or refer to a specific data element contained within the tensor data structure. So a tensor's rank tells us how many indexes are needed to refer to a specific element within the tensor. So rank is just telling us how many indexes that are required to access a specific element. Next is axis of a tensor. If we have a tensor and we want to refer to a specific dimension, we use the word axis in deep learning. So the real definition of axis is an axis of a tensor is a specific dimension of a tensor. So if a rank represents the total dimensions of a tensor or the number of total indexes that are required to access elements, then an axis is just a specific dimension, just only one of the dimensions. For example, if we say that a tensor is a rank 2 tensor, we mean that the tensor has 2 dimensions, or equivalently, the tensor has 2 axes. So it's a rank 2 tensor, but it also has 2 axes, one along the row and another one through the columns. Elements are said to exist or run along an axis, and this running is constrained by the length of each axis. Now let's see an example for an axis of a tensor. So a tensor with 3 axes is depicted by the first figure. As we can see that this is a rank 3 tensor because it has 3 dimensions. One along the width, another one through the height, and the other one through the depth. And each dimension can be identified by using an axis. One axis runs along the width, another one goes through the height, and the other one goes through the depth. So the first axis has 3 we can identify 3 elements using the first axis. Using the second axis, we can identify 2 elements, and using the third axis, we can identify 5 elements. And the second figure shows us another tensor with 4 axes. So since it has 4 axes, then it has 4 dimensions. And since the fourth dimension only has 2 elements, so it's going to be a block, and it's going to have dimensions of 5, 3, 4, 2. Or if we go along or it might be 3, 4, 5, 2, depending on which dimension you put first. And the elements can be identified by using 4 indexes or 4 axes. The next term that we need to clarify is the length of an axis. The length of each axis tells us how many indexes are available along each axis. So if we say an axis is just a dimension, a specific dimension, then the length of a single axis refers to the number of elements of each axis. Suppose we have a tensor called T, and we know that the first axis has a length of 3, while the second axis has a length of 4. So the shape can be identified by 3 by 4, and the length of each axis is, for the first axis it's 3, and for the second axis it's 4. Since the first axis has a length of 3, this means that we can index 3 positions along the first axis like this. So if we want to access the first axis or a dimension, we can identify 3 elements by using the indexes 0, 1, and 2. All of these indexes are valid, but we can't move past index 2 because it's limited, because it only has 3 axes along the first dimension. And since the second axis has a length of 4, we can index 4 positions along the second axis. So for each of the first axis, we can identify 3 other elements. So the first block shows us identifying the first element along the second axis. The second block shows us along the second element for the second axis. And we go on to the third block. We can identify the third element for the second axis. And finally, we have the fourth block. So for each of for the first element of the first axis, we can identify 4 elements for the second axis. The reason that we are clarifying these terms is because we need to be really good in identifying the shape, axis, rank of a tensor when we start working with PyTorch. The next term is the shape of a tensor. And the shape of a tensor is determined by the length of each axis. So if we know the shape of a given tensor, then we know the length of each axis. And this tells us how many indexes are available along each axis. So the definition for the shape of a tensor is just, it gives us the length of each axis of the tensor. We have already defined the length of an axis from the previous slide. So the shape is just the length of the axis for each axis, and we combine them together to find the shape. So for example, the shape of 3 by 3 tells us that each axis of this rank 2 tensor has a length of 3, which means that we have 3 indexes available along each axis. So we have 3 indexes for the first axis and 3 indexes for the second axis. So this figure shows us an example for the shape of a tensor. So the first one is a 1D array. and through the axis of 0 we can identify 4 elements. So the shape is just 4. This can be confused with another tensor, which is a 4 by 1. If that's the case, a 4 by 1 tensor is just has 4 rows and 1 column, and it is a vector. But a 1D array only has 4 elements, and it doesn't have a second dimension. So when we start working with a tensor, we have to convert a NumPy array, which only has 4 elements, into a 4 by 1 tensor before we start putting it into the model. So we will see why this is important when we start working on the coding project. The second one shows us a 2D array with a shape of 2 by 3, and the first axis goes along, axis 0 goes along the row, and axis 1 goes along the column. And the third one shows us 3 dimensions, 4 by 3 by 2. Finally, for reshaping a tensor, reshaping changes the shape but not the underlying data elements. One thing to notice about reshaping is that the product of the component values in the shape must equal to the total number of elements in the tensor. So when we want to reshape a tensor with specific dimensions, we have to make sure that the output after the reshaping operation also has the same number of elements. So if we have a tensor with a shape of 3 by 3, it has a total of 9 elements, so we can reshape it into a 1 by 9 tensor because it also has 9 number of elements. Now we're going to see how to implement the concept of rank, axis, and shape using PyTorch. Now, let's say we have a 2D array DD, and it's a 3 by 4 tensor, and we can access 2 indices of the 0th row and second column by using 0 for the first index and 2 for the second axis, and we can see the output is 3, which is the 0th row and second column, 0, 1, 0, 0, 0, 1, and 0, 2. Now let's see how to access elements along the first axis. Each element along the first axis is an array. So for this example, let's define it here. There might be an indent. Now let's access the first row, and this is for the second row and the third row. So for a rank 2 tensor, we can use the first axis, and by using different indexes we can identify the different components. Now we are going to access elements along the second axis. To identify elements through the second axis, which means along the column, we can use the second axis and the second index 0 to identify elements along the second axis. Now, as you can see, we are identifying the elements along the column, the zeros column. Now, the shape of a tensor is determined by the length of each axis. So now let's convert the Python list into a tensor, and in order to do that we have to import torch, and by using torch.tensor we can convert a Python list into a tensor. Now after it's converted, we can see the tensor. Now as you can see, the list is converted into a tensor, and we know that it's the case because of the tensor function here. We can also see the type to make sure that it's a tensor, and as you can see, it's an object of the tensor class. In order to get the shape of the tensor, now we can use the dot shape attribute for the tensor class. Now let's output the size, and as we can see here, it's a 3 by 3, and it tells us that each axis of this rank 2 tensor has a length of 3, which means that we have 3 indexes available along each axis. The final concept that we need to demonstrate is reshaping. Now, reshaping changes the shape without changing the underlying data elements. So in order to reshape a 3 by 3 tensor, we need to have 9 elements in total. So we can reshape it into either in a 1 by 9 or a 9 by 1 tensor. So we can use the dot reshape method of the tensor class to reshape the tensor. Now, as you can see, the 3 by 3 tensor has been reshaped into a 1 by 9 tensor. Now, this is the output of the 3 by 3 tensor, and this is the output after it has been reshaped into a 1 by 9. And then finally we can see that the size or the shape is a 3 by 3 tensor here, and for the second one it's a 1 by 9. That's all for this video, and in the next video we're gonna see how to create tensors by using different methods. We have already seen one method to create a tensor by using the tensor method, but there are a lot of ways to create a tensor other than this one. So in order to clarify that, we're going to use another video. Thank you for watching, and subscribe to my channel.
Audio Jungle.